Hello, we are looking at a question from TMUA, um, and this is from 2017, paper 1, question 6. It talks about a tangent to the circle passing through the point 20, 0 and crossing the positive y-axis. What is the value of y at the point where the tangent meets the y-axis? So we definitely need a decent diagram for this. So let's draw a circle. Well, it's centered the origin and the radius is 12, and then it talks about a point at 20, 0, so that's out here, and it's a tangent to the circle, positive y-axis, so there are two tangents, but the one we want is the positive one, so that's going to be something like that, and we want to find the distance between here and here, so I'm going to call that h. And there's something to be said for trying to work out this point here. Maybe work out the equation of this line and work out where that line then crosses the y-axis. However, that looks to me as if it's going to take more than 6 minutes, 6 minutes being the average sort of time you should take for a TMUA question. So is there a quicker way of approaching this question? And the way I think we can approach it is to try and, well, let's put in this radius here, because we know that that radius by circle theorems hits the tangent at a right angle, and now we've created a triangle here of which we know some things. We know this length here is 20. We know that any diameter of the circle is 12. Right, 12 here then. But then if we think about this other triangle up here, this triangle here, we're looking for the hypotenuse. If we can find the length of the hypotenuse of this smaller triangle, then we've solved the problem. We've got the hypotenuse of this one, which is 20. So, and we've got this length here, 12. So let's consider some angles. Let's call this angle in here alpha. If this is alpha, then that's 90 minus alpha. So this angle here must be alpha. So we've got that angle in there. And then if this angle here is beta, then alpha and beta must add up to 90. So alpha, if this is alpha in here, then this angle in here is beta. And suddenly we're looking at two similar triangles. So we've got a similar triangle question where the hypotenuse here is h, the hypotenuse here is 20, we've got a common side here with 12, so what we're interested in to start with at least is this length here. We can work that out though from Pythagoras. We've got, it's the square root of 20 squared, 400, minus 12 squared, 144 square rooted. So that's 256, square root of that is 16. So we've got this length here. So now we can say that h compared to the hypotenuse, h is the hypotenuse of the smaller triangle, the hypotenuse of the larger triangle is 20, equals, well, what have we got? We are comparing, we've got the 16 here, which is the length between the alpha and the right angle. And so that's the one on the bottom. And the one between the alpha and the right angle here is 12. So all we need to do now is rearrange and solve this. So h is 12 over 16, which simplifies to 3 over 4, times 20. 4 goes into that, 5 times 3 times 5 is 15, and that's our answer. 15 is the height, and sure enough, we've got our options available here, and 15 is B, and that's our answer.